gentle, and of course very modern apes, it's finally time. We're going to discuss the Aquatic Ape Hypothesis today. I've been getting a lot of emails about this one. Maybe it's just that summer is creeping up here in the Northern Hemisphere, and that is where most of the people who watch my channel are from, so they got the ocean on the brain, and they want to hear, kind of the thoughts of your favorite local gentle and modern ape on this idea. And most of my thoughts on that idea are negative. In my anthropology department, the aquatic ape hypothesis is something of a punching bag. People bring it up when they're talking about bad hypotheses, and this probably has to do with the nature of the hypothesis itself. It's not very well founded, it's something of a just so story, and it comes from a weird background. But until now, I felt I didn't really have kind of a pressing reason to talk about the aquatic ape hypothesis, and I found one, and that reason is called Robert Sepehr. Robert Sepehr is a chronically incorrect goon who writes and makes videos about a lot of different stuff. Now, I have thoughts on Robert Sepehr and about an oil tanker's worth of disdain for the man, but these thoughts are long-winded, and I'm going to save them for another time. Instead of talking about Robert Sepehr the guy today, we're just going to talk about Robert Sepehr's Aquatic Ape Hypothesis video, and we might take some light jabs at him. Now, part of the reason for this is Robert Sepehr has like a legion of very rabid fans who will descend upon any channel that dares to criticize their esoteric daddy. And what I would like to do is first have a video or two to kind of build my case that while Robert Sepehr the person is horrible, he is also just wrong all the time. And this is a very impressive feat given Robert Sepehr talks about a lot of different things and manages to be wrong about most of them. He does a lot of pretty wacky videos, as you can see. He's got the Serpent City below Los Angeles, the secret sect of sin, pagan origins of Valentine's Day. We got lost children of Hercules, white giants of the New World, ancient goddesses of above and below, Nikola Tesla's rediscovery of free energy, and Nordics and UFO disclosure. There's a lot of really weird shit in here, and I feel the need to let you know that if it's not inherently obvious, Robert Sepehr is like if you took the entire content catalog of Gaia's streaming service and distilled it into a single living person. Then you would have Robert Sepehr as he emerges out of some kind of like egg sac. And yet, 342,000 subs on his YouTube channel here. And he's got another one. He's got Atlantean Gardens. He talks about Atlantis a lot, guys. That's something else that should become increasingly evident. Where he's got 238,000 subscribers. So the man is popular, and I think that we should go ahead and do a little deep dive of our own into his coverage of the aquatic ape hypothesis, which he has decided to call the aquatic ape theory, and then he puts his name in like jumbo-sized letters right next to it. Now you might be looking at this and saying, cosmic disclosure. What a weird way to start a video. No. This is not Robert's intro. This is Gaia's targeted ad in front of Robert Sepehr videos. Obviously, this is Gaia. You can tell right off the bat. And over to the side, you can see other sort of weird esoteric videos, classic for Robert Sepehr's audience. As you can see, the algorithm is very fine-tuned here. We have the dark age of ancient Egypt, 100% pure human resonance for grounding consciousness. We have the believing brain, evolution, neuroscience, and the spiritual instinct. The anti-Kythera mechanism, a shocking discovery from ancient Greece. Lots of stuff on the Mayas, lots of stuff on UFOs, all sorts of weird stuff. So you can really kind of get an idea of the world that we are about to envelop ourselves in. So really we're kind of evaluating two things here. We're evaluating the aquatic ape hypothesis and also Robert's coverage and fact-checking of it. So let's get started.
On a hot summer's day, there's no place I'd rather be than the beach, as the water is not only refreshing to swim in, but also seems to clear the mind, offering some psychological benefits to be around, which is why I suspect that it has always attracted so many people for thousands of years to live along the shores of beaches, rivers, and lakes.
Robert loves to start these videos off, all of them, with very personal monologues and shots of him doing some kind of activity. That's how he starts almost every single one of them. And I gotta say, like, it's actually my favorite part of the Robert Sepehr videos because he's usually not talking about something stupid. Now, what Robert said there is true. Like, humans do tend to settle around rivers, lakes, oceans, but in places like ancient Mesopotamia, the reason humans settled in the Fertile Crescent in between the Tigris and Euphrates River, one of the oldest civilizations or record of civilizations that we have, was not because they found peace by the riverside. It's because humans need water to live. But Robert's going to be doing this a lot, and he has done this a lot in many of his videos. It's a common pseudoscientific strategy. You take an observation, and of that observation, there are, a million different sort of conventional, reasonable, non-out-of-this-world explanations, and then like a handful of pretty crazy explanations that may or may not mesh with the observation, and like Robert's type and the Gaia types will 100 times out of 100 go with the weird explanation for something. It's the complete opposite of Occam's razor. It's like Occam's spork.
In fact, almost half of the world's population lives within 60 miles of a coast, which got me thinking about one of the most interesting theories in the field of anthropology called the aquatic ape, which proposes that the ancestors of modern humans developed in a water habitat.
So it's totally true. Most people do live close to water features. In fact, there was a publication somewhat recently that kind of broke this down by region. Around 70% of people live within 5 kilometers of the closest nearby water bodies, something like a pond or a river or a lake or the coast itself. This number goes up to 80% in temperate or like northerly regions, and it goes down to 55% in arid regions, probably just due to the actual frequency by which you can find water bodies of any given kind. Obviously, it's harder to find a lake to live by when you're living in the Sahara than it is if you're living in the land of the lakes, like Canada. But again, this isn't a human thing, this is a mammal thing. Mammals need water to survive. They cannot live without it. Which is why mammals that live in habitats that are arid or like they're living in deserts, they have natural adaptations for a lifestyle in these locations. Perhaps they're superb at thermoregulation, something that humans have really jacked up to 11. Maybe they have different behavioral strategies to avoid water loss, like ranging near water bodies themselves, or perhaps coming out late at night when it's cooler and they lose less water to the sun. There's a million different ways to skin a cat in this case, but the bottom line is mammals do need water. They have to rehydrate. The easiest way to stay hydrated is to live near a water body. I liked the pithy definition of the aquatic ape hypothesis, though. Let's see where he takes it.
There have been several authors who have made contributions to this theory, such as the German pathologist Max Westonhoffer.
Westonhoffer is a complicated figure because on one hand, he's known for his work in public health. He went over to Chile, worked at a university there, and published an expose on bad sanitation practices, which made him very popular among his medical students and some of the leftist parties of the country, but also got him deported by the higher-ups of Chile. They weren't a big fan of being put on blast like that. But Westonhoffer is also known for something else. He's known for being one of the chairs of the German Society for Racial Hygiene. And the year that he was president, or chair rather, of that organization was 1922. And it's a eugenics organization.
Well, Robert Sepehr, that's extremely suspicious. Committing genocide is not cool.
So, like I said, complicated figure. And this may perhaps provide some of the first hints on why I don't like Robert Sepehr. Oh, also Westonhoffer abandoned the aquatic ape contributions that he provided later in life.
Discussed various human characteristics that could have derived from an aquatic past. For example, humans are relatively hairless, the lack of fur making the body much more aquadynamic.
So humans aren't relatively hairless. In fact, we have about 5 million hair follicles on our bodies, which is approximately the same amount that we see in chimpanzees and indeed most other primates. The difference between us and chimps is twofold. One, our hair, or at least our body hair, is much finer. It's not as coarse, so it's not as obvious. So we are actually, in fact, covered in fur. It's just very fine fur. The other difference is our eccrine glands. We have 3 times the amount of eccrine glands, or sweat glands, that chimpanzees or other panins have, which is really interesting and impressive, and perhaps lends itself to the alternative reason as to why our hair might be fine or more aquadynamic, as Sepehr would say, which is that we've reduced the hair so we can more efficiently sweat. And he's going to talk about sweating a little bit later, and I'm excited to discuss that as well.
Another uniquely human trait, when compared to primates, is that people have a layer of subcutaneous fat, which no other primate has, but is common in sea mammals such as dolphins, whales, and seals.
So, this is incorrect. Humans are not the only primates with subcutaneous body fat. In fact, wild primates will usually have 9% or less, while humans range. Human women who are considered fit will tend to have 21 to 24% body fat, and men are going to have 14 to 17%. Thanks, breasts. Seals, on the other hand, have around 40% subcutaneous fat, and whales can get up to 80%. This is not comparable. Also, some seals have body hair, like a lot of fur, and that kind of is in violation of that earlier point there, huh, Robert?
Of course, the most interesting feature is why do humans walk upright, which I will talk about in a little bit. Humans have webbed fingers, which he claimed hinted at a semi-aquatic lifestyle in our evolutionary history.
Oh, good. We'll get to the bipedality stuff later. I'm sure it's very reasonable. Humans also don't have webbed fingers and webbed toes unless you have, like, syndactyly. They're no more webbed than any other primate's hands or feet.
The regression of the olfactory organ, or shape of the nose, where while swimming, water rolls away from the nostrils, diminishing the chance of it entering the airways.
I think he's actually made a mistake there. I think the regression of the olfactory organ is talking about a reduction in the size of our olfactory bulbs and the genes which are turned on to manage them, which is reduced not only in humans, but all primates. Smell is not an important sense for us. We use vision instead. The olfactory organ, I think, I do think he means the nose, but if anything, the nose has, come out and forward. It's hooded forward, unlike most other primates, other than the proboscis monkeys, which tend to have flatter noses. It's also weird because downward pointing nostrils seems to be the only nostril type and orientation that is not found in any known marine animals, right? Cetaceans have a blowhole that opens to the top, and most pinnipeds, or seals, walruses, things like that, their nostrils just point forward. So it seems like you can't really make that connection. Moreover, if you could, wouldn't that just mean that proboscis monkeys too descend from an aquatic ancestor?
As well as the ability to hold our breath for prolonged periods.
So not only can other apes hold their breath, but monkeys can too. Rhesus macaques and long-tailed macaques, Macaca mulatta and Macaca fascicularis respectively, often hold their breath when they go swimming and dive under the water to exploit the resources there.
Speaking of breathing, another thing that I love about coming to the beach is sitting in the cool breeze and taking in the fresh air. While most people assume that forests produce all of the Earth's oxygen, in actuality, trees are only partly responsible, as up to 70 to 80% of the air we breathe, depending on the season, comes from algae in the water.
This is all good and correct. Want to see where he takes it?
While some algae floats near the surface to use sunlight for photosynthesis, there's also a type of algae that survives down by underwater volcanic vents, totally independent of any sunlight, that performs chemosynthesis in total darkness, a process by which chemical energy from vents is turned into usable energy, and an entire food chain is supported independent of any sunlight. This fact becomes even more interesting considering that there are rivers, lakes, and even oceans of water below the surface that we rarely think about, as there are many large subterranean caves that theoretically could be life-sustaining, meaning one could probably breathe and live miles below the surface, assuming that there's water, algae, and a food chain which does not require sunlight.
So let's follow him with this, right? Algae produces oxygen when it photosynthesizes on the surface. Photosynthesis, remember, produces oxygen as a byproduct. There is also algae near hydrothermal vents, and hydrothermal vents can supply their own ecosystems down there. Therefore, cave systems, which also have lakes and rivers, which may also have hydrothermal vents with algae that is undergoing chemosynthesis, could potentially, and here's the implication, right, sustain a population of subterranean hominins. Problem number one, chemosynthesis doesn't produce oxygen as a byproduct, so how are these guys breathing underground? Problem number two, how did they get underground? What ancestral population of primates managed to crawl down into the caves and evolve into hominins down there? Not to mention, at the same time this is happening, I guess hominins are just also evolving in a convergent fashion on the surface from African Miocene apes, which are then evolving into bipedal hominins and then bipedal big brain hominins. It doesn't make any sense. Why would it be homoplasic bipedalism with big brains on top of and below the surface? Problem number three, what are they eating, right? If it's sustaining this nice ecosystem, that's all fine and dandy for things like crabs, but you know what doesn't live near hydrothermal vents? Giant marine mammals that breathe oxygen.
That said, in a subterranean environment, especially in caves, there are several known types of fungi, or lichen, that glow and produce light. Since caves are void of wind, which is what usually blows mushroom spores around and helps them to propagate, there's a higher rate of glowing fungi in caves, as the light attracts insects and animals which touch them and thereby help to propagate their spores. The less windy the environment, the more common it is to have glowing species. So, as nice as it is on the surface with the blue skies, fresh air, and waves, there must also be underground cave systems that have water, oxygen, possibly fish, crabs, and other marine animals, glowing mushrooms or lichen, which is a plant-based like organism that has a symbiotic relationship with fungus, which can glow and is edible.
So, couple problems there. Problem number one, photosynthesis, not chemosynthesis, has oxygen as a byproduct. And you know what photosynthesizers need? Light. Sunlight, specifically. Photo means light. They have to have light. And you know where there isn't light? In caves. So chemosynthesis is not going to cut it, unless there's some pretty weird organisms out there that I guess I'm just not aware of that Robert does know about. Now, you don't have to necessarily have a plant to do photosynthesis, but all of the photosynthesizers do need light. Problem number two, insects are animals. I don't know why he was like animals and insects or insects and animals. Those are the same thing. Kingdom Animalia, right? And problem number three, calling lichen, just kind of like a plant-like organism, that's a little too simplistic. But more importantly, the fact that some fungi and lichen, like protists and things like that, is photosynthetic and also edible, does not solve all of the other problems I mentioned. This man is just treating The Descent, the movie The Descent, like a documentary. But actually, I think it's even worse than that, because I think in The Descent, the hominins were already hominins before they descended back into the subterranean caves, right? It's not like that's where they evolved initially.
If a subterranean environment has breathable oxygen, a sustainable food chain, and enough light to see in, then an evolutionary habitat below the surface becomes more plausible, and might explain why some lighter skin tones do not seem very well adapted to the harmful ultraviolet spectrum from the sun.
It's a red flag party, everybody.
Me? I'm the Riddler. I'm not racist.
Like, this is one of the basic concepts in human evolution. You would be hard-pressed to take a human evolution class and not get anything with regards to why we have the spectrum of skin colors that we have within our species. And the reason is pretty simple. So light skin colors and dark skin colors have both evolved more than one time, and it typically has to do with folate versus vitamin D. Sunlight destroys folate in large amounts due to the UV radiation, and you need sunlight to spur the synthesis of vitamin D. And so what you basically have is a balancing act. If you have dark skin, you can protect the folate, but you might have a vitamin D deficiency. If you have light skin, the folate is at risk, but you're getting plenty of vitamin D. This has nothing to do with hominins evolving in caves.
In all my years of study, I've never come across a single religion or mythology that places humanity's origins as having come down from the monkeys in the trees. Yet I can cite numerous examples from around the world of myths and legends that claim that people first emerged from underground.
So, if an ancient religion has to talk about it in order for it to hold scientific merit in the modern world, we can pretty much throw out every science textbook ever. I don't know of any ancient religions that, for instance, talk about the germ theory of disease or quantum mechanics, and yet here we are, utilizing them in scientific trials and everyday life. Additionally, sharing aspects of one's mythology does not mean that it is true or holds any seed of a truth value. Most religions have, for example, trickster deities and human-animal hybrids. That doesn't mean that human-animal hybrids literally existed or that trickster deities are walking among us today. It just means that there's something collectively shared about human nature. We try to solve things in similar ways. Now, next, Sepehr is going to start talking about some examples of cultures that have humans as originating from underground. Again, I gesture to my previous statements. I'm not going to show it because I don't think that it matters.
In fact, many researchers from a broad spectrum of sciences do not subscribe to the evolutionary sequence proposed by Charles Darwin, which states that small mammals called prosimians took to the trees about 60 million years ago, evolving into monkeys, which then came down from the trees and evolved into great apes, which then began to walk upright about 5 to 8 million years ago, evolving into hominins, or people.
I'm sure we're going to get loads of citations for all these scientists that don't think human evolution is legitimate. But I'm also going to nitpick, and the reason I'm going to nitpick here is because if you're going to overturn the conventional paradigm, you should probably know your stuff, and Robert Sepehr does not. He's shown this on other occasions too. For instance, when I was on Myth Vision with Derek, we covered his debunking out of Africa video, and there were many basic errors in it with regard to biological anthropology. But here, for example, he talks about prosimians evolving 60 million years ago and taking to the trees. Prosimians did not exist then. This would be kind of pre-prosimians even, things like Plesiadapiforms or Purgatorius, stuff like that. He also discusses great apes having evolved after monkeys come down from the trees. That's not what the Miocene says. We've got well over 24 Miocene apes that are very much still arboreal.
The German pathologist Max Westonhoffer doesn't believe that humans are primates at all.
I don't know if he held that opinion or not. I couldn't find really anything on it, and what I could find was in German. But if he did hold that opinion, he's objectively wrong. The definition of a primate is pretty simple, and it defines a really big group of animals that humans just so happen to fall into when you include us in the animal kingdom, which you should because we're also a part of the kingdom of Animalia. For instance, primates have big brains for their body sizes. They have forward-facing eyes or binocular vision that can see a wide variety of colors. We have nails that tip our digits instead of claws, and we have unique structures in our wrists and ankles to aid in our mobility. We also tend to live in unique social structures that can come in a variety of forms, and we tend to give birth to only one kid at a time, that is. We don't have litters. We also have an incredibly poor sense of smell, and this goes down to the genetics too. We simply have fewer genes that are turned on dedicated to processing and capturing smell. We also have short muzzles, and we take a long time to grow up. There really is no way to get around classifying humans or Homo sapiens within the order primates, any more than there is a way to keep us from being within the class Mammalia or the kingdom Animalia, or closer down within the family Hominidae.
While it is true that humans share over 90% similar DNA with primates, please keep in mind that house cats share 90% of its DNA with humans. Mice and humans share, on average, about 85% of their DNA, and people share about 80% of their DNA with cows. In fact, we share 61% of our DNA with fruit flies, and 60% of our DNA with a banana.
Spoken like someone who doesn't know a single thing about genetics, this should be super concerning. So you can compare the genetics of organisms in a bunch of different ways. You can look at specific proteins, you can look at sections of proteins, you can look at whole genomes, and looking at whole genomes is the best way really to do it. This is typically what we do when we're running things like paternity tests, which are of course admissible in court, but you can also compare the genomes of closely related or suspected closely related species. This is what we did with humans and chimpanzees, and then bonobos, gorillas, and orangutans. And what we found is that when we're comparing the genomes of a human and a chimpanzee, and we're just looking at alignable regions, that is, we're not including indels, humans and chimps are 98.8% identical in their genomes. When you include indels, that number falls down to about 96%. Now, whether you're looking at the coding included, or the indels included or the indels excluded, humans and chimps are still more closely related than rats are to mice. That is to say, they're very, very similar, genomically speaking. Bonobos are about the same. Gorillas come in next, then orangutans, and rhesus macaques are around 92-ish%, depending on, again, what you're looking at. But are humans and bananas really 60% similar? No, of course not. In fact, that number is kind of a thorn in my side, so much so that I did a video on it that's long form. You can find the link in the description, but the long and short of it is that number comes from comparing orthologous proteins, so just proteins, not whole genomes, and even then, the number is wrong. So humans are 17 to 25% similar to bananas when looking at protein coding genes, but less than 1% identical when looking at all the DNA in their respective genomes. The fact of the matter is, comparative genomics is the only way to tell how closely related two given individuals are, whether we're looking at a parent and a kid, or we're looking at two siblings within the same species, or whether we're looking at two suspected closely related species or distantly related species. Genome comparison is the only way to do it reliably. Robert is trying to cast doubt on that because he's going to paint something very different. The ironic part is, he is also going to invoke the power of genetics later, and he will also get it wrong there too.
So genetics can be misleading when one does not understand DNA.
Bold of you to say that, Robert.
Because much of the shared DNA is silent and is not involved in the coding sequence. While it might still be true that humans and other primates share a common ancestor in the remote past, the identity and origins of this ancestor is what is increasingly coming into doubt, as is the entire out of Africa hypothesis.
Life could be a dream if I could take you up in paradise up above. If you would tell me I'm the only one that you love, life could be.
But now, I hope that you will appreciate the massive, massive section of this video that is just an old TED Talk or conversation or interview or whatever with Elaine Morgan, the sort of modern propagator of the aquatic ape hypothesis. Elaine Morgan has since passed away. I think she's quite charming. I think she's quite cool. Robert is going to interrupt periodically to give us his thoughts. And I'm going to probably skip around here and there. She gives a lot of history and things like that, which is cool. It's interesting to hear her take on things. But this is supposed to be an aquatic ape video, and already it's mostly been a Sepehr's weird out of Africa and blood type takes and racial takes, so let's hopefully steer it back.
If you look at the last 20 books to be published on human evolution, including textbooks and encyclopedias, 500 pages long, and there is not a mention in these books of the fact that we have lost our body hair.
So I can't speak to the textbooks that were out and circulating when Elaine Morgan gave this talk in 2008, but typically textbooks are going to discuss primarily the skeletal material, so adaptations for bipedalism, the adaptations in the hands and wrist with regard to tool making, bigger brains, things like that, because as it turns out, hair does not fossilize very frequently. Fortunately for us, recent genetic work has given a rough estimate for when we think we started getting hairless, and the number that's been bobbing around is 1.2 million years ago. So it had been around the time of Homo erectus. Homo erectus is also one of the hominins that is accredited for being one of the more efficient bipeds in genus Homo. This really gets turned up to 11 with Homo sapiens. But it seems quite reasonable to me that Homo erectus, a very efficient biped who was capable of running long distances, would also have a very efficient means of thermoregulating itself. Comparative studies, too, of humans and other primates show that there does seem to be a relationship between how much hair we have, how thick the hair is, and how many eccrine glands or sweat glands we have. So thermoregulation takes two steps, the loss of hair and the gain of sweat glands. And these two things in tandem help us to sweat, cool our skin, and maintain activity in the heat for longer. Elaine also talks about isotopic work that shows that around the time of the Australopithecines, and indeed a bit earlier with Ardipithecus, that we weren't living in savanna environments, so the savanna hypothesis should be kicked out the door. Now, I'm not a particular fan of the savanna hypothesis anyways, but the savanna hypothesis exists only to kind of lend support or lend an idea for why bipedality may have evolved. It doesn't necessarily have anything to do directly with being hairless or with sweating. So bipedality has many different hypotheses for why it may have emerged, but the savanna hypothesis was popular for a long time until it was shown that Australopithecines and indeed Ardipithecus, who were already coming down from the trees and utilizing their suite of bipedal characteristics to get around, were living probably in woodland environments. So it wouldn't have been coming down from the trees in a savanna environment that forced them to stand up, but rather as the environment changed around them, they were already a bit predisposed for moving around on 2 feet. This suite of characteristics would include things like an anteriorly placed foramen magnum, foot morphology including 3 arches and an inline big toe, things like a bowl-shaped pelvis with sagittally oriented iliac blades, and a valgus knee fit for carrying the weight directly underneath the body. As for why bipedality developed, I'm partial to a sort of foraging hypothesis. Today, apes like chimpanzees and gorillas will sometimes nest in the trees while they'll move around on the ground during the day foraging. So I think something similar may have happened back in the late Miocene with some of our Miocene apes, including things like Ardipithecus cadaba. These animals would live in the trees during the nighttime where it was safe, away from predators, and come down from the trees during the daytime to move from tree patch to tree patch in this woodland environment that they seem to have inhabited. Ardipithecus only has some of the suite of characteristics of a biped. Its toe looks like that. It's pretty bonkers. But Australopithecus has all of the characteristics necessary for a biped, and its world was changing around it as well. So I think it's just as reasonable as anything else to suggest that it was the ability to move from tree patch to tree patch that allowed organisms in a rather spread out environment to more efficiently exploit resources. As for why sweating and the hairlessness developed, I think that given it's more recent in time, just as persistence hunting is thought to be, that may be our explanation. The ability to run for long distances required a need to more efficiently thermoregulate, so we ditched the fur and we gained the sweat, and it made us an unstoppable powerhouse of moving long distances, whether it be following game trails and hunting or just migrating here and there. The bottom line is, I don't think it's aquatic ape hypothesis or savanna. I think there's a whole suite of different hypotheses that exist to help explain why our ancestors became bipedal, and also separately, but also linked due to evolutionary pathways and such, the ability to sweat and our loss of our fur in favor of much finer hair.
A major proponent of the aquatic theory was a marine biologist named Sir Alister Hardy, who specialized in the study of plankton, a basic component of the marine food chain and something Hardy was knighted for. He invented a device in 1925 to better record plankton levels and map out the distribution of different varieties.
Well, that sounds kind of reasonable.
Hardy was also into spirituality. He believed that psychic abilities, such as telepathy, may have also played a role in influencing evolution and particularly early human development.
Okay.
Oh, You almost had us there, Robert. Elaine talks briefly about Alister Hardy. She leaves out a lot of the telepathy stuff and basically says that as a marine biologist, he noticed similarities with the subcutaneous fat found in humans and the subcutaneous fat found in other marine mammals. Again, while humans do have more subcutaneous fat than other primates, we're nowhere near the levels of any marine mammal that I was able to suss up, from pinnipeds to cetaceans. Elaine Morgan also talks quite a bit about how fat human babies are, human babies being like 5 times as fat as a chimp baby when a chimp baby is first born, and I think honestly, a lot of this boils down to the fact that humans are even more altricial than chimpanzees. That is, our babies are born even more helpless. A baby chimp is pretty helpless, but it can still hold on to its mother's fur and get around that way. Human babies can't really do anything at all. They're kind of just squirming little meatloafs that require their mother's help for everything. However, their brain is already starting to grow and it's already starting to soak in its surroundings. And a lot of people think that the reason human babies are so fat is that they need that nutrition in order to power their spongy little brains as they begin to grow it. I actually think that Elaine seems quite reasonable when she's presenting her case. I just still think that she's wrong. I think she's not considering a bunch of other hypotheses that are out there for, again, things like bipedality and thermoregulation. And I think that a lot of the things that she points to and that Hardy pointed to that make humans seem more aquatic have other explanations. We sweat and can afford water loss because we drink so much water and are capable of carrying our water with us. It's more important for us to be able to cool down in the moment and rehydrate later. We're one of the most water efficient apes out there. Oh, our babies are kind of fat? Well, our babies are also born with enormous brains for their body sizes, and they utilize a whole lot of energy even though all they're doing is laying around. Perhaps it's going to fueling that noggin, huh? So I think Morgan, is eloquent, but I think she's incorrect. And then we get to hear more from Robert Sepehr. Awesome.
While many sources, such as Wikipedia, do in fact denounce the aquatic ape theory, I'd like to point out that it is taught at the university level, and if it had no merit, why is it still part of the curriculum?
So I just finished taking hominin evolution at a graduate level. I'm a PhD first year student, just finishing the first year, and we didn't talk about the aquatic ape hypothesis once. We didn't even bring it up to make fun of it in that class. We talked about the savanna hypothesis, we talked about various dietary hypotheses, hypotheses for why we have big brains, hypotheses for why we sweat. Usually it's like the heat hypothesis or persistence hunting hypothesis, things like that, but no aquatic ape. Sorry, Robert, you're wrong.
Let us make a list of all the ways in which we differ from apes. Nobody seems to have done that. And let us find where else do you find these characteristics.
So the first thing Elaine brings up is hairlessness and other hairless animals, because humans are the most naked, quote unquote, of all the primates. So she asks the question, what can we learn from other hairless animals and why they are hairless? She points to cetaceans, so whales and dolphins, they're hairless to be more aquadynamic. She points to pinnipeds, so certain types of seals and walruses. And she effectively says that the reason humans are hairless is because of potentially an aquatic lifestyle. The problem with this is, one, some seals have fur, right? So some eared seals do have fur, and they're still plenty aquadynamic. She also brings up elephants, and she proposes that elephants may have had an ancestor that was semi-aquatic, because here we have elephants, they're big, they're about as hairy as humans are, except they even lack the impressive head hair or manes that we have. And she proposes that their ancestor must have just been semi-aquatic. The problem with that is Erytherium, which is the oldest proboscidean that we know of, lived 60 million years ago. So at this point, I don't know that you can blame the ancestor. They're very clearly adapted as hairless now so that they can have efficient thermoregulation for such large body sizes. And then there's the issue of other large mammals that are hairless, like rhinoceros or certain suids, which don't seem to have any hint of an aquatic past, and yet they're large and relatively hairless. They're hairless so that they can thermoregulate. This is, again, what's also been proposed for humans as to why we lost the hair and gained the sweat glands. It may be that we lost the hair to thermoregulate and the sweat glands to really thermoregulate well. She also points out that the only time that other primates get up on 2 feet is when they're wading through the water, and thus maybe that's the reason why humans adopted a bipedal stance initially as well. The The problem with this kind of goes with her earlier point. Early bipedal hominins like Ardipithecus and Australopithecus lived in woodland environments, not swamps or by the coast. Then she talks about the subcutaneous fat layer, which we already touched on. Humans are nowhere near the sub-Q fat level of marine mammals. She talks about the descended larynx, which is something that only humans and bizarrely enough a species of red deer seem to have. But I would like to point out that humans don't have a descended larynx at birth. We develop it through life. So clearly this is an adaptation that doesn't come into play, interestingly enough, until about when we start talking. So this seems, if anything, to be more of an adaptation for communication and maybe even language than for being a marine animal. She talks briefly about how humans have large brains for our body size, but instead of making the connection that like cetaceans have pretty large brains, she goes the route of the only way to have these big brains and fuel them efficiently is to have a proper balance of, I think it's omega-6 and omega-3s, which can be most easily found in like coastal diets, with like crabs and fish and things of that nature. But the problem with that is that many individuals today eat no seafood at all, and they seem to get along just fine fueling their large brains. Not to mention ancient people groups of the past did this too. We didn't always live by the coast. Nomadic people groups especially kind of bucked this trend. She suggests that maybe it only needed to be present during this brain expansion, but if anything, I think that you would need to show that we need it now still, or at least it's very helpful now still, since our brains have kind of reached a maximum here. She talks about the reduced ability of the sense of smell in humans by the reduction of the olfactory bulb when compared to chimpanzees. And the human olfactory bulb is smaller than what we see in chimps, even though our brain is larger, but it's really not that substantial, and given primates in general have a massive reduction in their olfactory sense anyways, it seems to me that this is more of an even further relaxed pressure for maintaining the olfactory bulb given the change in diet that humans and hominins underwent as compared to chimpanzees. For instance, humans and, late hominins, early genus Homo, likely incorporated meat into the diet. So you don't really need to be able to have an excellent sense of smell to see game across the savannah, but you do if you're foraging for things like figs, which is something chimpanzees still do and still need to do in order to feed themselves and give birth to healthy offspring and then raise them. She talks about voluntary breath control as something that only humans can do, but as we discussed earlier, this is not the case. Other apes can hold their breath voluntarily as well. Now, Morgan links it to speech, basically. She says that you can't train an ape to talk because they don't have the breath control to do it. But as far as I know, the reason they can't speak is a combination of tongue morphology restraints and also cognitive restraints on their system. Then, I kid you not, Robert starts talking about how humans didn't actually develop sweating in order to persistence hunt because of their lack of prognathism, which suggests an agricultural diet.
I think she makes a fair point there. In school, they argue that modern humans needed to sweat to hunt, but the lack of prognathism points to an agricultural diet, as does certain aspects of some blood types.
That sounds like the dumbest thing I've ever heard.
This is just gibberish. Prognathism refers to the relative snoutiness of an organism. It's sort of like the projection of the face, either alveolar prognathism or full mid-face prognathism. Humans have relatively flat faces compared to other primates, but prognathism has nothing to do with diet. As for blood types and agriculture, that's really silly, right? I don't even know what to say to that. I'm sure there's some kind of Atlantean explanation.
I also find it interesting how babies can be born into water, totally immersed in water, and instinctively know how to hold their breath.
Yeah, you want to know what that reflex is called, Robert? You really want to know? The mammalian dive reflex strikes again. Robert finishes with Elaine Morgan at a TED Talk, and she says some funny stuff. I actually do think she's kind of a funny lady. And then he hits us with his closing, which is this.
Yes, if they were wrong about Piltdown Man, and wrong about Nebraska Man, and wrong about Out of Africa in terms of race, then they can be wrong about primatology, as there's absolutely no primate fossil record. Every monkey or ape bones you've ever seen have come from a modern specimen, probably from a zoo, and the primate fossil record does not exist.
Interestingly enough, my dissertation is on Miocene apes, and let me tell you, there are more of them than we know what to do with. This isn't just the case for the Miocene apes, of course. We have plenty of monkeys that come before them, and indeed strepsirrhines and tarsieriforms that come before them. But I'm just going to go ahead and tell you the Miocene apes, if you will. Indulge me. You got Camoeopithecus, Proconsul, Akembo, Rookwapithecus, if you want to include some of the old world monkeys, Victoriapithecus and Prohylobates. You have Griphopithecus, Equatorius, Kenyapithecus, Afropithecus, Morodopithecus. You could get up into the Asian early hominoids, which includes things like Shivapithecus, Indopithecus, Lufingpithecus, Gigantopithecus, of course. We have to include some of our Middle Eastern and, of course, European hominoids in the list. We can't forget them, like Gracopithecus, Oranopithecus, Rudopithecus, Hispanopithecus, Oreopithecus, and Dryopithecus.
My name is Robert Sepehr. I'm an anthropologist. My published work is available on Amazon.
Anyways, it's always nice to see Robert shirtless and getting into a hot tub. What a great, classy, elegant way to end a video. I'm going to leave my comments about Robert Sepehr again for another time, but what I am going to do is talk a little bit more about the aquatic ape hypothesis and some of its problems. I think the main issue with the aquatic ape is that we simply don't have any support for it, biogeographically speaking or anatomically. All of the anatomical characteristics that are supposed to link humans as these intrinsically water-loving primates have other explanations that seem to knit quite nicely together with the hominin fossil record, which is also, of course, in East, Central, and South Africa, and not on the coasts. The problem with the aquatic ape hypothesis, as others have said, is that it simply isn't parsimonious. This is a classic graphic that's presented for the aquatic ape, and everything on it can be explained by something else or is like special pleading. So for instance, it talks about dark pigment blocking sunlight in tropical waters. Yeah, or savanna environments, or any place on the equator. Reduced body hair and smooth skin to reduce drag. Yeah, or help thermoregulate. Scoop-like hands with a thumb webbing to help catch water, flexible arms and shoulders, and rare condition of webbed fingers. The rare condition of webbed fingers, again, is syndactyly, it's pathologic, and the other two are also great for climbing trees, which is something that we carry as a part of our past. And of course, our scoop-like hands are a primitive condition. Miocene apes have the same hand proportions that we do. We've simply exapted them to be excellent at making tools, which is another pretty cool thing if you ask me. Hair growth patterns follow the water flow. They just grow in normal directions. Armpits and pubic hair reduce turbulent flow in concave surfaces. Okay? They just grow the way that they do. This has absolutely no adaptation in the water. Lower normal body temperature with low fluctuations like in aquatic mammals. Human body temperature is like pretty similar to every other primate, so this may as well be the case for long-tailed macaques, for instance. Sub-Q fat layer and fusiform straight streamlined body. We talked about both of this. The fat layer is potentially to help fuel the brain, and the fusiform body is to help being with our bipedal locomotion. Webbed toes and force exerted on the first and last toes, like in seals, paddle-like feet. All of these are just special pleading explanations of the adaptations that exist for bipedality. For diving and foraging, all of these talk about the ability to forage for food underwater, and these are all just worse versions of natural marine foragers. So it talks about things like agile neck for searching. Craning your neck like this when you're swimming, it hurts your neck after a while. You get sore. Seals don't get sore because their bodies are naturally built for underwater foraging. A flexible backbone, yeah, or a flexible backbone that's great for absorbing shock while you're running. Things like multi-pyramidal kidneys, which excrete salt from seawater, yeah, or just help us filter out in general our urine. talks about things like birth. Again, the mammalian dive reflex, which is something that all infant mammals have. Umbilical cord long enough for a newborn to reach the water surface. At what depth, right? Like, again, it's super special pleading. Talking about things like the genital. I kid you not, there's something on here that longer penis in response to deeper vagina. What? It's talking about the foreskin avoids infection in seawater. Huh? What? None of this makes any sense. This is absolutely ridiculous. Kind of funny. Kind of a shit post, but greasy hair for waterproofing. Yeah, except some people have dry hair and there's 100 different kinds of hair types that exist in natural human variation. Eyebrows and eyelashes prevent water flow into eyes. Yeah, or they just, like a brow ridge, prevent rain or sweat from getting in your eyes. All of these are just they're not parsimonious as an explanation. They don't fit together to form a nice story. It's just a bunch of attempted straw grasps that end in something that's just kind of silly. I mean, if anything, like most of these traits, again, exist in crab-tailed or crab-eating macaques. Long-tailed macaques are the same thing. Let me show you. Long-tailed macaque swimming. Just turn it into the aquatic monkey hypothesis, because these guys swim and dive just like humans do. And they eat shellfish naturally, and they live on the coast. The males have long penises. It's just kind of silly. And so, with that, I'm going to kind of wrap the aquatic ape portion of this video up. And I'm just going to say the aquatic ape is silly, and Robert Sepehr is sillier. Elaine Morgan meant well, and I really do think she's a smart lady, but I do think she was also wrong. And so, my gentle and, of course, very modern apes, I hope this went swimmingly for you. It sure did for me. Thanks for being here, and I'll see you next time.